Ever wondered how satellites track ships at sea, especially when clouds or darkness might hide them from view? Today, we're diving into a groundbreaking approach that's redefining ocean monitoring. Imagine a satellite that doesn't just collect data but thinks on the spot, spotting ships in real time. That's exactly what this research is achieving. Let's start with a big picture. Synthetic Aperture Radar (SAR) is like a superhero radar system. It can see through clouds, night, and even rough seas. But here's the catch. Traditional methods collect massive raw SAR data, send it all back to Earth, and then analyze it. That's slow, expensive, and bandwidth-heavy. What if we could process this data on the satellite itself? That's where lightweight neural networks come in. Think of it as giving the satellite a tiny, super smart detective. Instead of sending every pixel back to Earth, the satellite uses a neural network to spot ships and just send key details, like their location. This cuts data volume and speeds up response times. But here's the challenge. Satellites have limited power and memory. So the team designed super compact AI models that run on specialized chips called FPGAs, customizable computer chips that adapt to the task. The research focused on two SAR data types, Stripmap and interferometric wide, IW modes. Stripmap is like a high-resolution snapshot, while IW covers wider areas but with less detail. The team trained their neural networks to work directly with raw or range-compressed data, early processing stages that still hold crucial clues about ocean targets. Their secret weapon, a YOLO-style architecture. You might know YOLO as a fast object detection system. Here, they tweaked it to work with SAR data, using ResNet blocks, think of them as building blocks for neural networks, to balance speed and accuracy. The model doesn't just detect ships, it predicts their exact coordinates, slashing the data sent back to Earth. And the results? Let's talk numbers. On Stripmap data, their smallest model achieved a near-perfect 98% accuracy in detecting ships. For IW data, even with complex scenes, they hit competitive scores. But the real wow factor? They deployed the model on a Xilinx FPGA and made it process data in real time, like a satellite with a brain that keeps up with the speed of the ocean. Here's where it gets even cooler. They didn't just detect ships, they classified them. By training the model to distinguish between ships and windmills, yes, windmills, they showed this AI could filter false positives. Imagine a satellite that's not just looking for targets, but understanding its environment. But not all radar data is equal. When they tried the same approach on IW data, think of it as a wide area scan. The raw signals were too scattered. So they applied range compression, a technique that focuses the radar's energy on targets, making them easier to spot. By tweaking the model's input size and complexity, they improved detection and added classification, like telling a ship apart from a windmill. Of course, no tech is perfect. They hit a roadblock near shorelines, where clutter from structures and vessels confused the model. But this isn't a dead end, it's a clue. The researchers think more diverse training data could fix this, and future satellites like the upcoming Sentinel-1, equipped with AIS tracking, might help automatically label data. Picture satellites that not only capture images, but also tag what they see, making training data a breeze. So what's the big deal? This work shows deep learning can tackle raw radar data efficiently, opening doors for real-time ocean monitoring. Whether it's tracking shipping lanes, spotting illegal fishing, or monitoring climate change, this tech is paving the way for smarter, faster satellite systems. And as datasets grow richer, who knows what other secrets radar signals might reveal. Thanks for watching. If you want to dive deeper into how AI is reshaping remote sensing, hit subscribe, and let me know in the comments what other tech topics you'd love to explore. Until next time.